box. My name is Hafsa. I'm from People Powered Retrofit, which is a one-stop retrofit shop based in Greater Manchester, and we're hosting today alongside John from Zero Carbon Harrogate. So I'll let John give himself a little bit of an introduction.
Hello, my name's John Kerr. I'm the Retrofit Programme Manager for Zero Carbon Harrogate. Well, I hope this is the very first of our online series for Retrofit, essentially trying to help people understand, certainly the trades, understand what's going on within retrofit, and bring them up to speed as much as we can. So, as I said, it's the first in the series of two, and we hope with the feedback that we get from these that we'll be offering more training services. Through the funding that we've got, we're looking to expand our available free training in pretty much all the trades, including renewables installation. But so watch this space, and we'd really appreciate any feedback that you'd like to give us, any areas that you feel that we've missed out on, etc. Because we're very much at the start of this and just learning. Thanks for listening and viewing.
Great, thanks, John. And this webinar is being recorded, and you will be sent a copy of the recording. So don't worry too much about scribbling down notes too quickly. I will pass on to Florence and Richard, who are joining us today to give us sort of real life experience of retrofit.
I'll just share my screen now, and hopefully I can start the slideshow from here. Does that work? You've got the full size slide?
Yeah.
Yeah. Great. Well, it's lovely to be here. Thanks for inviting us, Hafsa and John. I'm Florence Collier. I'm a passive house designer, a mechanical engineer in building services, and a retrofit assessor with People Powered Retrofit. So I set up Humblebee about nearly 5 years ago now. And sort of retrofit seems to be where it's all happening at the moment, but I've had the privilege to work on my own house and involve Richard's team as the installation aspects of it, which is obviously the bit that you're most being interested in. But I thought I'd give you an overview of the design, how we got to some of the decisions that we took beforehand, and some of the principles of a low energy design, and some of the targets that you could be achieving with it. So this is how it looked probably this time last year. The panels, about this time last year. This is what it looked like beforehand. On the left, a standard 70s brick cavity wall building with a horrendous PVC false portico, and it's a 4-bed detached. Did I say 4? Yes, it's 4 beds. It's 3 beds in the study. And this is what it looks like now, with some front steps out front, and these shutters that took us about a year to eventually get up to the windows, because this is due southwest. So we were keen to keep the sun out of the southwest facing bedrooms. You can see the lockdown rainbows on those original windows at the time. Passive house is very much a sort of top standard for energy efficiency and air quality, indoor air quality and comfort. And the passive house standard as it is, and some of the higher classes tend to apply to new builds, but there is a passive house standard for retrofit called Retrofit. Although you're stuck with a certain, pretty much stuck with a certain orientation and form, which are two of the major pillars of passive house, you can act on all the other aspects of the construction to make it more like passive house. it recognises that you can't quite get the thermal bridging, the air tightness, the orientation. So there's the target consumption, which is specific heat consumption per square metre per year, is slightly higher than you would a normal a new build passive house. This is the sort of diagram that you would get from the people powered retrofit assessment. We go around to your house, take some measurements, look at the construction using the quality of the windows, the installations, etc. We put this into a model, and you get we end up with a baseline. We calibrate that to your energy bills to see how much, because you might be using it in a certain way, using a heating system in a certain way with a certain schedule. So we calibrate it to your baseline, and it gives sort of a heat loss per degree difference between inside and outside, based on all those inputs. It's somewhere between, in terms of accuracy or prediction, it's somewhere between the building regs software, the SAP software model, and the passive house model. So it's somewhere in between. So it's a bit more accurate than the, it's a lot more accurate than the building regs version. It's not quite got all the information that passive house would expect on the model, but it allows us to apply some measures, and you get sort of cost up some scenarios and phases. So you can see how our phase 1 here has reduced the total heat loss from 460 to 150 watts per Kelvin. We went through a planning process, because in Cheshire East, where I am, they just default to the national planning framework. I'm not too sure about Harrogate, you'll just have to go on the portal to find out the specifics. But because we were using different materials to the original construction, it falls under a planning application scenario as opposed to permitted development. And what we decided we would do was try and use natural materials as much as possible. This allows the brickwork, the masonry to breathe, although we're trying to keep air tightness. It's more about vapour being able to migrate between the layers of the construction as a vapour, not condense anywhere. And so we've got wood fibre insulation with render and timber cladding. We've got wood fibre loft insulation and hemp insulation in the loft. And I'm so excited because today we started insulating the floor, and I can show you live what my floor looks like now after a day's work. So that's great. We've got triple glazed timber frame windows from Green Building Store, which this is just showing a little bit of the prep work, and my son having fun demolishing a porch out the back. So yeah, we started with the loft, and we thought that was something we could do DIY until I fell through the roof. This was through the ceiling in the middle of lockdown, having told all the children, stop running around, stop using sharp knives, we're not taking you to A&E. But this was, yeah, my experience. Luckily, I fell onto my daughter's bed, so all was well, and I didn't have to go to A&E. And you can read about all this, all these anecdotes on my blog, and also I've been totally transparent about costs, bearing in mind this was last year, with supply chain costs going up, and we started with, in terms of getting other people involved, we started with the cavity wall insulation. This is grey PVS speed, and it gets pumped in various holes in the mortar. We only had a 50mm cavity, so but it's still worth insulating like that. These were the very heavy but highly insulating and well-made green building steel triple glazed windows with timber. So the natural timber is the inside, and then the outside is sort of powder coated this nice green colour, which we chose. And we went from sort of multiple panes to as few panes as possible, because a lot of the heat loss in a window is through the frame. So if you minimise that as much as possible, then you're doing as much as you can for the building. Not sure how I'm doing for time. Yeah. So the windows went in first, and they went into a ply box so that we could push them out into the insulation layer, and that allows us to minimise the thermal bridging. And we've got this external insulation, which is wood fibre board. So two types of wood fibre. The outer is weather protected and a little bit more dense, I think. So we've got two different thermal characteristics. So that's something to watch out when you're trying to work out the U value overall, is how, which boards go where and how thick they are. They're stuck to the masonry using a mortar. This is the Valmet system. And then up to the DPM level, we have an XPS plinth, so we don't whip any moisture out up from the ground. And I think Richard could tell you a bit more about the details of those. So part of the works was to build a trench around the outside so that we could bring that insulation down past the floor, the actual ground bearing parts. And yeah, so this is it a little bit further down the line with the scaffolding up and the boards going up on the first level. We went for inward opening windows so that the insulation could go over the frame, and again minimising the thermal bridge across there. And this is it. So whilst when the scaffolding was up there, the team were like, did you know your concrete tiles were now getting to the end of their life? And actually it made a lot of sense, because we did see, whenever it we had a bit of frost or snow, we did have lines of drips in our lofts, which basically indicates them being porous and no longer really working as a weatherproof layer. So this was our chance to re-roof and get because we had the scaffold up, we thought, well, this is also our chance to get solar panels up there, which was originally supposed to be a second phase, but yeah. Yeah, I don't know if you can see, but we managed to get hold of some reclaimed slate from Cheshire Demolition. So really nice slate off an old mill, and that's 14 panels up here, and we've got another 4 on the back. So this is southwest facing, the other one was east northeast, and yeah, we're reaping the benefits when it's a sunny day, unlike today. That membrane is the airtight windproof membrane, that goes behind so the render will give the weather and windproofing for most of this, but where we decided to have some timber cladding, we have a membrane behind it. And yeah, airtightness, what we're trying to achieve with an MFIT and a passive house is a continuous line across the section in 3 dimensions, of where there's basically no gap for any air to either escape or infiltrate the sides. And you've got your different standards, so the ACB level 2 retrofit, for example, has a slightly higher allowance than pass or NFITs, and this tends to be the NFIT one tends to be very difficult to achieve in an existing building, but not impossible. So that's as far as we can try and get. And then in terms of ventilation, which was we managed to get to install a mechanical ventilation system that has heat recovery. So you can use natural ventilation in buildings, but it does mean that most of the time you're bringing cold air in and extracting that through your bathrooms and just throwing it out. With MVHR, you bring in fresh filtered air, and before it gets into the room, it gets preheated by the air that's coming out through your bathrooms and kitchens. So it's a lot more efficient from a heating point of view, and the amount of energy that you use for the fans is just a fraction of what you would normally use for your heating. Air tightness, this is just to illustrate the amount of heat loss that infiltration can represent in your overall heat balance. So if this is the size of your heating system, immediately you can see if you can get your air tightness right down, you're getting a massive drop in how much you need to heat the space, because basically the cold air that's coming in, you have to bring up to room temperature. It's notoriously difficult to estimate what that infiltration is, especially in an existing building. So we have air blower tests, and the passive house air blower test will test between sort of both with positive pressure, so you pressurize from the inside out and measure the leakage, and by depressurizing, so you measure what's coming in, because obviously if you think about a window and how it butts up, an openable window and how it butts up to a frame, in one scenario it's actually being pulled apart, and in another it's being pressed together, so you might get two different results. The ventilation system itself, you've got a choice of layout. So we opted for a branch layout with some metal ductwork, which is the more traditional way, with crosstalk attenuators between rooms, so you don't have transfer of noise. One of the easiest things to do in retrofit, though, is probably the radial layout. It very much depends on a case-by-case basis, but these are sort of semi-rigid plastic pipes that come off a manifold. They're all much smaller in diameter at this stage, so they're quite easy to install in floor voids and things. We decided to have ours in the lofts, but I wouldn't generally advise to do that. If you've got the space within the thermal envelope, you'll have the benefit of the higher efficiencies. So we're going to have to go back and insulate it a lot more, because we really suffered a drop in efficiency just because it's in a cold loft. And that's it going in and being commissioned on the right. On the left is Chris from Richard's team just trying it on for size. Because you have to, as soon as it's delivered, you need to check that all the parts are there. And that's really the end of my bit, and I'm sorry if I've gone over a little bit.
That was great. Thank you, Florence.
You're welcome. I've got some slides about heat pumps, but I think that's probably another webinar.
Right. And top tip: put mattresses in your rooms if you're insulating your loft, in case. Yeah. I'll pass on to Richard now.
Okay, I'll just share my screen. Okay. So hello everyone. I'm Richard from the Retrofit Hub, and I'm going to go through Florence's retrofit, the kind of some of the problems we encountered and what we try and the approach we try and take, and basically what we do. So yeah, and I'll try and summarize what I think is a good retrofit project. If I speak too quickly, or if you miss anything, then obviously ask a question at the end, and I'll try and clarify it for you. So I'm a retrofit coordinator and project manager for the Retrofit Hub. I started it about 4 or 5 years ago, but I initially started as an assessor, like Flo with Carbon Co-op. But I was also a heating engineer as well, so heat loss and heating is kind of in my blood. The team I've got that worked on Flo's job are probably the most experienced retrofitters in Manchester. I feel quite lucky that I've managed to snag them all. But they worked on some of the earliest projects that started in Manchester. There's a passive house development called Ernie Close, which I think was the first passive house development in Manchester. They're not just retrofitters; they're builders, joiners. They've got lots of experience in window fitting and ventilation systems. So yeah, it works well. We all kind of integrate and work well together. So what are the points that really make retrofit different from normal building, and what do we kind of need to do to make it a success? I think it's still things like good workmanship, attention to details, and taking pride in your work. You can't cut corners. It's kind of easy to throw up some plasterboard in a house and make it look beautiful, but it's not going to perform if you don't think about the performance as kind of a core thing in the build. It's also it's kind of a balancing act. It's not just the performance. There's also things that we take into account, things like moisture and air tightness. Sometimes it's a compromise between those different aspects to make sure that you're not introducing problems into a building. It helps if you have a good design team who do a lot of the design to start off and get it all right before you even get on the site. But you can't mitigate for what people have done in the past. So you're almost guaranteed to find things that you didn't expect when you start getting into a build. You're changing the building physics. So although you can model it and you can plan it, there's always going to be things that are going to knock you off course. Things like the external wall insulation, the wood fiber we used is it doesn't have to be a 2-board system. It can be a single board through the whole assembly. But I think part of the reason why we had the 2 boards is because the Natural History Museum nicked all the wood fiber in the country for one of their projects. So we had to get the right thickness, we had to change the specification a little bit. So Flo's house is a 1960s house, but I just wanted to run through how that differs from a more traditional older house. Older houses are they're built with lime normally, and they're a bit more breathable, so moisture would naturally go in and out of them. They have a lot more ventilation in them, or infiltration. So if you were to retrofit them, you have to be considerate to that, and you can't just throw in kind of foam boards and plastics, because you can cause a lot of problems with it. So you have to be sympathetic to the type of building. Flo's is a 1960s house. It's suspended timber floors. Normally cavity walls were empty in those days. Then the roof loft installations at the rafter level, ceiling joist level. Obviously, it probably would have had single glazing when it was built, but normally they have double glazing now. And again, drafty. We have quite drafty, leaky houses in the UK. Air tightness has not been a consideration really, and it can be quite a job to improve a house and make it airtight. Again, that's where design comes in right at the beginning. So Flo's already run through this. We did triple glazed windows. We filled the cavity wall and then externally insulated it. Flo increased the insulation at by herself before we even got there, so that was all nicely done for us. And I think the ceiling was repaired as well. So the mechanical ventilation with heat recovery we put in as well, and as Flo says, we're just about to start, or we've had our first day of putting the floor in. It was suspended timber, which has a fair bit of problems attached to it that you can cause a lot of issues with it. So one of the decisions we made was that we're going to change it to a solid floor, which is entirely possible, but again, it needs kind of the correct parameters to do it. That you need to take care of moisture and damp and all that sort of thing. So this is an example of one of the things that a building can throw at you when you start retrofitting it. The pink areas in the diagram are the insulation. So across the ceiling, you've got standard loft insulation. There's cavity insulation in between the two leaves of brick, and then external on the outside. But because of the way the roof joins onto the wall, it's virtually impossible to get insulation in there. It's really difficult to get it from inside, and it's difficult to then get the insulation from the outside to marry up with it. It means you can end up with a really bad cold bridge at the edges of houses. A lot of houses from the kind of 30s and earlier have coombs where the roof actually cuts across the corner of the room, and these are normally really bad. You end up with terrible condensation on them. So we were kind of lucky that the decision was made to take the roof off, because it meant we could then insulate that area around it and get it right up to the rafters while still allowing ventilation from outside to inside the roof space. If you don't have that benefit, then you're stuck trying to get something in, and it's not always ideal. It certainly shouldn't be an afterthought, because it's one of those areas that you can have a real problem. As Flo mentioned, we put the windows into a timber box so that they're in the same plane as the external wall insulation, so you reduce the thermal bridge. Because they're so far out into the insulation, you can't support them on brackets, so we put them in a timber box. But then that adds an issue all of its own, that you then need to try and make that airtight around the window. So I think you can see in the photograph at the bottom that although we foamed the outside, that won't make an airtight seal, and it's although it'll make it weathertight, you'll still get air coming through that, even though we use a type of foam that's classed as airtight. So we had quite a long conversation when we put them in, how we're going to deal with the air tightness on the inside. And as you can see, that's the start of the solution, where we used airtight tape to tape the boxes and to tape the box to the brick reveal around the window. That will eventually get fully taped in and then parged over and sealed in, so that you can guarantee that you've got a really airtight seal around the window. There's no point putting really expensive windows in if you're just going to allow a huge amount of air to come in around them. The more airtight you make a building, the more those weak points become really noticeable. If you do an air tightness test with a thermography camera, you can really see the air coming around windows. That they're a really bad weak point in houses. And I have to say, your average window installer probably doesn't understand the problems they're causing when they leave windows not airtight or not sealed properly. So this is the halfway, the first day of the floor. It's about 600 mil deep, which is about perfect for what we're going to do. We'll be taking the joists out, taking the sleeper walls out, adding hardcore in to about 300 or 400 mil, and then on top of that, using a foam glass, which is a recycled glass pebble, which has got an insulating effect on it. And then on top of that, there'll be a rammed earth floor going in. But our job is to make sure that we don't allow any moisture or too much moisture to come up through the floor and affect the higher layers. So again, we had a chat with Flo and the guy who's doing the rammed earth to work out what the best details will be for that. And you can see on the bottom photograph the joist pockets going into the wall. That they're a classic problem that a lot of people forget or don't realize could be an issue, because the joists sit on the inner brickwork. They can penetrate through into the cavity on the outside. So it's just a massive air break into the floor. So you may well put you could do internal wall insulation and think you've made the room airtight, but if you don't target those areas, you're still going to get a huge amount of air coming into the room, and it's kind of negates a lot of the effort you might go to. So we're kind of lucky that they're coming out in a way. We'll take them out, we'll parge the walls, we'll make it all airtight, and then we'll build the floor around it. Yeah, so that's going to be an interesting one. It's not one we've done before either, so I'm sure that'll end up on Flo's blog in the coming weeks. So as I've said, what makes a successful retrofit? Certainly a good design at the beginning, having a real plan for what you're going to do, what the best solutions are, how you're going to integrate all the different measures together. But because my guys all do different things and we all work together, it's quite easy to plan the work and integrate it together. But if you've got a lot of different trades who are coming in from different companies with different skills, it can be troubling to try and get them all to work on the same page. It's a problem in British building, I think, that sometimes trades don't always work together and can be detrimental to each other. I think the plan you need to start with can go awry really quickly. So having an engaged design team and an engaged client is also key to a great retrofit. That it probably takes a little bit more patience and a little bit more determination to do a good retrofit. That we do have a lot of solutions for a lot of the things that we do, but we also have to do things on the fly as well and try and work out how we're going to deal with things as we go. So being ready to deviate from the plan is also an important aspect. Yeah, and I think that's it. I think I've actually rattled through that quite quickly, haven't I? So I just want to say thank you for listening. If you've got any questions, obviously we've probably got a little bit more time for them, then I'll answer them and try and clarify anything I've said. Shall I pass it back to you, Hafsa?
Yeah, that's great. Thank you so much, Richard. John, I don't know if you're able to disable people's mics, and if anybody does have any questions, you can raise your hand or you can pop it in the chat box. and we can ask our speakers.
I've just got the detail of the floor up if you wanted to have a quick look at that. That's what we're aiming for.
Great.
The compacted subsoil, foam glass insulation, and then we're hoping not to have much heating, so we're just going to have a couple of electric rads dotted about the place. So we're not going to do this whole underfloor heating pipe installation. We're going straight for the top coat, well, a base layer and a top coat, I think. So that's that.
Wonderful. Okay, we've got a question from Julia.
Oh, can't hear you.
Still muted, sorry.
I'm trying. Technology says it's mic's enabled, but for some reason it's not letting.
Yeah, it does say actually that it is enabled. It's not being our friend tonight, is it?
No.
Microsoft Teams. Yeah, it might be that. Are you able to click it at all, Julia? It might just take a minute. Or if we can. Oh, I think she's typing it in.
While we're waiting for Julia, I'd like to also make people aware that we've produced three videos that are based around the building regulations L, O, and F, which would be really worth having a look at. So they come in terms of retrofit and how those regulations, or how retrofit affects those regulations, or and obviously recent changes since June last year. So definitely worth a look at those videos to kind of refresh. If not renew and expand your knowledge in terms of that. Right, can you see that?
Have you used airtight membranes in the floor and loft insulation? Not yet, no. And so the idea will be, I haven't quite sealed the ceiling yet. At the moment it's just the old plasterboards, so they've got a few holes in them and things like that. So the top floor isn't airtight yet, but the idea is that I think the way we're going to go is we're going to use OSB boards to tape together, and then have maybe a service void, a very shallow one, just for some new lighting wiring. Below that, we haven't got a huge amount of head height, so I might change my mind completely, but we'll see. And then on the floor, so the geotextile isn't airtight, but I think because it's all rammed earth and it's oiled and waxed, if they so the pard coat is going all the way down to the subfloor, so that should seal the room. Is that right, Richard?
Yeah, so the pard coat will marry up to the plaster on the walls on the ground floor, so that'll take care of the walls, and then like Flo says, the rammed earth at the top will be is deep enough to be airtight. And I think there's a cork board down the side, isn't there, behind the skirting, which will be airtight. So although it's not a membrane, it will be airtight across the floor.
I'm thinking of no skirting board.
Yeah.
So well, yeah, something to work out as we go. Not mind.
Yeah, I think when we get to that bit, we can give you another detail of it.
You think I might change my mind? Very good.
Great.
It's certainly, I was just going to say, you know, from my perspective, it's certainly, you have to approach this with a very flexible mindset, because every building presents a different set of challenges in terms of and what you can achieve. And, you know, I think obviously Richard said, you know, you've got to kind of be prepared to change tack and use of other products to try and to solve the problem. Yeah, it can be quite challenging.
So Julia's asked a question on the chat. Am I planning to install an air source heat pump? I'm hoping, well, no, is a short answer. Even though that's the kind of thing I design. So we're aiming to do this level of retrofit on the fabric and the air tightness, so that and what we've found actually living in the house so far is just the fact that we've got triple glazing and really insulated walls. We don't have this sort of temperature asymmetry about the house or any drafts, uncomfortable drafts. So actually we can live quite comfortably at a lower temperature of 18, 19 degrees, when all these calculations are done for internal temperatures of 20, 21 degrees, for example. And some people like their houses a bit warmer, but actually we felt absolutely fine just with, you know, couple of extra layers. So we are hoping that despite the electricity prices shooting up as they are, that we will get away with just a couple of electric radiators. And then because we've got the solar panels, hoping to get a hot water tank, hot water cylinder with a PV diverter, so any excess energy that we generate on the roof goes straight to heat the water, and it's an energy store, as it were, from that point of view. So fingers crossed. The calculations suggest we should be okay, but and we can just, you know, we can still afford those bills, but we'll see.
But for the record, using PV within the water tank is very effective. We've had a mixed use system in since end of September last year.
Yeah.
And yeah, it's extremely effective.
Oh, brilliant! Yeah, mixed use is the tank I was looking at. So definitely, that's really good.
Yeah, very controllable in terms of that you know basically only heat what you need.
Yeah.
But also the amount that it heats up really quickly, you know, using the PV. Even we were starting to get return in February.
Oh, wow.
On that,
Amazing.
you know, coming out of winter, so which is really good.
Yeah. Oh, thank you, John.
You're welcome.
Because I always have the theory, but you know, there's the other heads saying, yeah, but you know, in practice, so it's nice to hear.
I think we kind of get so wedded to central heating that you just expect to have a boiler pumping out loads of heat, and that when you go against that and go for a deep retrofit, it's about behavior change as well, isn't it? It's difficult to get used to that lower temperature and the fact that you don't need so much. Yeah.
Well, that lack of drafts, is we don't realise how much they affect how we feel in a building, and by eliminating those, have a significant effect. And you know, like you say, is that whole habit in terms of our habitual change in terms of how we heat our houses and how we live in them.
Yeah, totally. And the other thing is, so wood fibre has actually got quite it's quite dense, and it does have thermal mass to it, unlike some of the plastic foam type insulation. So you know, it evens out the temperature throughout the year as well.
A question come in from
yes, I saw that. So John has a battery, we don't. 13 kilowatt battery, that's huge. I decided, my husband kept saying, I need a battery. I decided it wasn't worth the expense or the sort of material scarcity. Well, with good energy anyway, so I know that every kilowatt hour that we buy has been generated renewably somewhere. And actually, we didn't really have anywhere to put it apart from the garage. There isn't a way to extinguish a battery fire at the moment. So if you do get a battery fire, you just have to let it burn out. So there are some risks associated with getting batteries, and they are quite expensive. So, every household will have its own sort of balance to do. These are the pros and these are the cons. If lowering your running costs and using as much of what you produce on site as possible is your priority, then by all means get a battery. But if you're happy with the concept of being in balance throughout the year, feeding some of your energy to the grid and getting paid a pittance for it, then that's equally valid, I think, in my experience and in my head. In my head and my heart.
John, did you have a reason for choosing to have a battery?
Well, for us, it felt like it made sense, and we've had I'd say over a year and a half, nearly 2 years. I think we've had that battery in. It works well for us. We're very low power users, so even on relatively dull days, we can we're not drawing from the grid at all. So in the depths of winter, we are using low cost tariff through the night. We have an electric vehicle as well, which is generally why we're doing that. Unfortunately, our battery is not, as a lot of these technologies, they're not smart. I know that My Energy have brought out the Libby now, which works with a lot of the other products that we have in the house. What I mean by that is that if we want to charge our car up, it sees the battery, so it empties the battery before it will take from the grid, which is what we don't want to do. And that's one of the problems with, from what I understand, all battery technologies, because they're all coming from different companies and nothing's working together that well. I believe the My Energy, but obviously that's all one product range that they make, and the Libby battery will work on that basis. But yeah, it works well for us. I kind of understand that. And it was a kind of a rush for PV and batteries, and certainly is interesting. We did a survey last year of the residents of Harrogate and asking them what were their main kind of energy saving interventions, and solar PV was number one and batteries was number two, which was a bit disappointing, in terms of if you're seeing your energy saving as that being the main intervention, whereas obviously addressing the fabric of the building is where you'd be best spending your money. It's a bit like the air source heat pump thing. If you can get your fabric that well sorted out, there's very little you'll need to use. So you could possibly avoid air source and look at other technologies. I mean, there's a lot coming out.
Yeah, totally.
Great. We've got another question in. If you've had a look at it, sort of in short, how do you manage expectations around costs? Because that's a big thing that comes.
It's a really good question.
Yeah, it is a good question. So I think you do need to sort of sit them down and say, well, you've asked for this, and it means this. And then they may or may not be able to prioritize what's really important to them. But I would say if they can afford to go for the wood fibre, and you can do it in more cost-effective ways than others, in the long term they will have the benefit of it. So if they're thinking of doing retrofit plus an extension or a brand new kitchen or something like that, maybe maybe they just need to rethink where they spend most of their money. And coming from where I am, it made more sense. So a lot of people sort of look at our house and they're like, so how much extra space did you get? And blah, blah, blah. And I'm like, that wasn't my priority. So, you know, yeah, you do have to manage expectations, having those conversations, and it might be, you know, an initial conversation, and you have to sort of plant the seed, carry on, you know, follow up. This is what it's costing. This is how we do it. That might mean building a bit less on your extension, or going for a second-hand kitchen as opposed to a new kitchen, or whatever it is, which is what we're planning to do.
I think it's I might be going against the grain by saying this, especially with Blow here, but I'm not sure it's always necessary to go to Retrofit. That you can get close to it.
True. Yeah.
We can make any house passive house as long as you've got the money, the time, and the determination to do it.
Yeah, but I don't think I will achieve benefit, by the way. But that was the sort of ultimate aspiration, and then as you go along, you kind of make decisions from a pragmatic point of view. So I'm going to see where I end up, but I hope to get AECB level, well, at least level 3, level 1. Oh, I can't remember which way it goes. It's recently changed. Anyway, at least an AECB level, if not one of the higher classes of those. So yeah, and definitely, yeah, show them the AECB website, and there's quite a few there are resources on that. Definitely.
Yeah, and I guess the wood fibre is the most expensive, and in some cases there are kind of halfway houses, or there's alternatives that you can use without going to PIR, or even just putting on a lesser amount of it to reduce costs. I'm presuming from the way the question's worded that the person asking it is a builder or specifier, and I guess it's a decision or a conversation I have with the designer as well, and see if there's any cost cutting they can do within the specification. It's really difficult from the contractor's point of view to reduce your costs if it's coming in over budget, because it costs what it costs, and the risk is that you end up cutting costs and cutting corners. And it's one of those things that trying to make people understand that it costs what it costs, and that if they go to someone else, or if they go with a different builder who gives them a much lower price, there's a reason why they've gone for that lower price. So yeah, it's a really difficult one. It's something I struggle with all the time. It's about having engaged clients and engaged design team, and trying to come up with a solution that fits everyone. Quite often it can be phasing a retrofit as well. So instead of trying to do it all in one go, doing aspects of it and then revisiting other bits later on when the budget's there. It's difficult. Things like if you're putting triple glazed windows in, or if you're thinking of doing external wall insulation, then ideally they should be done at the same time. But there can also be the most expensive aspects, and it can quite often mean that you either do the external insulation and do nothing else until the budget can be get for the rest of it. So yeah, it's difficult. And as Flo says, sometimes it can be about reducing other aspects of the build, so the size of the extension, or the cost of a kitchen. I found that a lot of people's the conversation we have with people has changed in recent years. That with me being a heating engineer and a plumber, I used to do a lot of bathrooms, and it was a struggle to get people to think about the energy efficiency of the house when they wanted like a really mega expensive bathroom. But now I think that's changed, and that people are more aware of it and want the energy efficiency as opposed to the gold taps.
Yeah. And then the other thing is, if they do it in phases, some building societies like Ecology specialize in sort of mortgages and loans for this kind of build. So it might be that they might add value, especially in this climate, but historically, doing energy efficient retrofit hasn't really added value to your property. But I think that's probably about to change.
Yeah, I think
so
that
you can borrow a bit more.
I think people are going to be aware of an EPC rating as well these days. That a lot of the clients I've had recently are people with really high energy bills, and that the more energy bills go up, the more affordable a retrofit is, because the quicker the payback is.
Yeah.
And that if people are struggling with bills, then to spend their, say, extension budget on a retrofit is more pragmatic, and I think it's going to happen more often. And people will choose houses that'll have lower EPC ratings.
There was one last question. I'm not sure I understand the wording. Do you generally feel batteries help use the electricity to meet your demand? Was that
I think because it was going back to the battery.
And was that a question for John?
Can you hear me?
Yeah.
Yes.
Yeah.
Yes.
Yeah.
No, that's going back to when we were having the conversation about the solar panels quite a while ago. That is, and I think we covered it off in the general conversation. Really.
Oh, okay, cool.
Yeah. Just to save labouring on.
Thanks for your question.
Thank you, John.
Can I just sort of bring something up in general? We're sort of like talking a lot about appearances and things, and vapor open, vapor closed, and how difficult it is to use foam boards and things. The aerogel boards, which are vapor open, but they're very thin and they've got very, very high insulating properties. But the thing that's a killer with them is that they're so expensive, aren't they? Yeah. Just in terms of you guys who are probably out there, particularly maybe from Richard's point of view, looking at different materials all the time. Is there any signs of anything in terms of like a vapor open board in a thin board with those similar properties, which might be coming to the market anytime soon, but far more affordable? I just get an impression it'd been, you look at a lot of problems that you talk about and things, and if you could really use aerogels just about anywhere, and you didn't have to worry about the cost of it, it'd result in issues, wouldn't it?
It's a great board, and it's got its uses. Window reveals is great for aerogel, because it's that thin thickness, but also they're not very big, so they're not going to cost a fortune. Unfortunately, it's just the physics of the way materials work, that it's the air that's trapped in the material that makes it insulating, means that you're not going to, unless it's aerogel, you're not going to get any insulation that's thinner for the U value you get from it.
I'm thinking in particular if you've got more traditional buildings with sort of like internal features and things, I think there's probably a lot of opportunities out there where you could use aerogel boards for those type of properties, but it's just so cost prohibitive, isn't it?
Yeah,
that's a problem.
So,
is there anything that anyone's heard of which sort of might be in development, or because I just picked up earlier on someone mentioned about different products that are in development now, things are rapidly changing.
No, there is so a lot of us, solid wall buildings, you can insulate from the inside, or you probably should insulate from the inside, just because they tend to have character and they're protected on the outside. And there is a cork-based restoration solution which is called diathanite. That's a sort of spray lime and cork. No, sorry, is it cork? Yeah, it's cork. lime and cork plaster on the inside. It's slightly more insulating for same thickness than wood fibre, so you can shave a little bit off. But again, you need about 60 mil to get some of the better U values. And if you want to push the U values of your internal wall insulation, you definitely needs dynamic agrometry modelling done. But the supplier will tend to do that for you, so you should be able to get it's called WUFI, the software, WUFI, and they'll do that analysis for you, which you'll need for building control anyway. So yeah.
Okay. Thanks.
Yeah, sorry, there's no magic solution,
No magic bullet, no.
But I'm very much a proponent of using the right material in the right context. So, you know, if you do need that thin material in a small amount of the build, then it's worth considering those things and just sort of juggling the budget around that way around.
Okay.
Great. Well, wonderful. Thank you. And thank you, Richard and Florence, for your time. I realise we've gone a little bit over, but great discussions. We'll send out an email with a recording once we've got it through, and also sort of links to Florence's blog and links to the videos that John had mentioned that Zero Carbon Harrogate have developed. But for now, thank you all for attending. And there is another webinar next week we've got Diane Hubbard and Helen Grimshaw joining us for Understanding Retrofit Performance Targets. It's on Tuesday, the 25th of July, and that one will be from 6:30 till 7:30.
Thank you very much.
Thank you.
Thank you, Richard. Thank you, Flo, and thank you, Hafsa.
You're very welcome.
Still got messages coming through.
Yeah, sorry, Rockwool is used quite a bit now, especially with insurance and fire considerations. But yeah, it has an embodied carbon aspect to it, but it's probably the go-to in the building trade at the moment, just for the fire aspect. And
certainly has its place, yeah.
Yeah.
Fabulous.
Cool.
Right. Okay. Thank you very much.
You're welcome. Thanks for having us.
Okay. Thank you.
Thanks very much. Thanks.
Cheers.
Bye-bye.
Bye.
Bye-bye.
Great. Was that okay? We'll see you soon.
Great. Thank you very much. Yeah. Definitely.
Well, yeah, let me know if you want to follow up on anything. And
yeah. Wonderful.
Cool.
Yeah. Thanks again.
Nice to meet you, John. Take care.
You too.
Bye. Nice to see
Cheerio.
you. Bye. Bye.
Bye. Okay. Are you okay with the I don't know if you're able to stop the recording? Yeah, I won't be able to. So just the 3 dots at the top where it says more, and then you click on record and transcribe, and you should be able to click stop recording.
There we go. Stop.